Since most of you came out of classes where you've discussed logs, and you should have come out of classes where you discussed logs, I'm just going to talk through some of the properties of logs that are important to us. So there's three properties that we're going to talk about here, and in a couple of minutes we're going to use them to solve some exponential equations. So the first property says if we have the log of a product, so the log of AB, that's the same as taking the log of A and adding to it the log of B. So we can turn multiplication, the log of a product, into the sum of the logs. Notice it does not matter what base we're in. So that's true for the common log, and notice it's true for the natural log. The natural log of AB is also equal to the natural log of A plus the natural log of B. So each of our properties will have a common log version and a natural log version, which are for all practical purposes the same version. Similarly, I have the log of division. If I have the log of a quotient, log of A over B, that's the same as log of A minus log of B. Similarly, the natural log of A over B is the natural log of A minus the natural log of B. Be very, very careful with this particular rule. Notice you need the log of a quantity. This does not work if you have log of A over log of B. It has to be log of the quantity A over B. And then the last rule is the log of B to the T is T log B, and that's the one we actually just used in the previous example. Similarly, the natural log of B to the T is T natural log of B. This one actually came out of, or is very much related to the first rule, because if you think of log of B to the T as being the log of B times B times B times B, however many of them you need, and we wrote it as a sum, we would actually get the log of B plus the log of B plus the log of B plus the log of B, and so we get whatever T versions of log of B. So that one actually is derived easily from the first one that we had.